This presentation provides an introduction to the MITRE CWE database. You'll learn how to access and navigate the information, where the entries come from, and why the recent extension of CWE for hardware is important for security verification. CWE stands for Common Weakness Enumeration. CWE is a community-developed list of software and hardware weakness types maintained by the MITRE Corporation and sponsored by the U.S. Department of Homeland Security, Cybersecurity and Infrastructure Security Agency. Other security-related databases maintained by MITRE that you might have heard of include CVE, which tracks common vulnerabilities and exposures, and CAPEC, which catalogs and classifies attack techniques. The common goal of these resources is to prevent vulnerabilities at the source by educating engineers building hardware and software systems. CWE can provide engineers with awareness about common weaknesses, which are errors, bugs, or flaws that, if left unaddressed, can lead to vulnerabilities. These common mistakes can then be eliminated before a product is deployed. A weakness that directly leads to a security breach in specific systems and products is called a vulnerability. CVE is a database of publicly known vulnerabilities. While weaknesses and vulnerabilities focus on design errors, CAPEC organizes strategies and techniques commonly employed by attackers to find and exploit vulnerabilities. CWE, CVE, and CAPEC were originally created for software, but now include hardware weaknesses, vulnerabilities, and attack techniques. Focusing in on CWE, the first version of the database to include hardware weaknesses was 4.0, which was released at the end of February 2020 and included 32 hardware weaknesses. Hardware CWE is rapidly growing due to industry interest in hardware security. Version 4.1, which was released 4 months later at the end of June 2020, saw the addition of 27 more hardware weaknesses, almost doubling the number of entries. One of the advantages of CWE is that it is a collaborative effort and leads to the sharing of security knowledge across multiple companies. Intel, Tortuga Logic, Wells Fargo, and others have contributed their knowledge to CWE. There are no restrictions on who can submit a CWE entry. Anyone interested in participating can learn more by consulting the link listed on the slide. When you first visit cwe.mitre.org, you will see 3 buttons that allow you to view lists of weaknesses by software development, hardware design, or research concepts. If you click on the hardware design view, or go to the link on the lower right-hand side of the slide, you will see a list of categories relevant to hardware. These include manufacturing and lifecycle management concerns, security flow issues, integration issues, and many more. Expanding the categories reveals a list consisting of classes and base weaknesses. Classes are denoted with a green C and are more general than base weaknesses, which are denoted by a blue B. Clicking on any item in the expanded taxonomy will bring up the entry. Each entry contains details describing the weakness, its relationship to other entries in CWE, modes of introduction, applicable platforms, common consequences, demonstrative or textbook examples, observed examples of the weakness, which typically point to CVE entries, mitigations, and references for further reading. For example, CWE 1243, exposure of security-sensitive fuse values during debug, speaks to how secrets can be extracted from the device by attackers if the test and debug interface is not adequately protected. This CWE entry is relevant if your design stores secrets and fuses and also has debug logic. This weakness, along with around 80% of the entries in version 4.1 of the database, can be covered by Tortuga Logic's Radix. In other videos in this series, we will dive into more details on how to use these CWE entries for threat modeling, security requirement creation, and security verification. At Tortuga Logic, we see hardware CWE as an important positive development for the entire hardware industry. CWE facilitates collaboration and sharing of security knowledge, which reduces the burden on individual companies to maintain their own private databases of security weaknesses. Hardware security is dynamic, and CWE is updated as new weaknesses are discovered. CWE also provides a standard measuring stick for comparing the coverage and scope of different security tools and can act as a common language for discussing how to mitigate hardware weaknesses. As industry-wide standardization around the terminology and taxonomy of common weaknesses gains more traction, we envision more fully integrated and automated flows based on the CWE lists that reduce the effort and overhead of secure design and security verification. Please visit our website for more resources on CWE and watch the other videos in this series for more details on how CWE can be used by your organization to streamline the security specification and verification process.